No challenge poses a greater threat to future generations than the climate change. Climate change is no longer some far off problem. It is happening here, it is happening now. Quoted Barack Obama. And on this note, let us start with today's report on direct air capture technology, a small step towards tackling climate change and sustainability. Direct air capture technology, or DAC, is a technology which captures carbon dioxide gas from the atmosphere by passing the air through reactors filled with chemicals which react only with carbon dioxide and makes the air carbon free. The captured carbon is then converted and stored permanently in deep geological formations such as rocks, or used in the production of fuels, chemicals, building materials, and other products containing carbon. When carbon dioxide is geologically stored, it is permanently removed from the atmosphere, resulting in negative emissions. Direct air capture technology is a fast-growing technology employed by various countries around the world, leading to 15 carbon capture plants, removing around 9,000 tons of carbon annually from the atmosphere. On 8 September 2021, Climework, a Swiss company, inaugurated Orca, world's largest direct air capture and storage plant in Iceland, along with its Icelandic partner Carbfix. The plant alone is capable of removing 4,000 tons of carbon dioxide each year. Being located adjacent to Icelandic energy company ON Power's geothermal power plant, Orca completely runs on renewable energy. The plant was built in 15 months using a modular system which claims to have a small physical footprint, cuts construction time, and can be replicated anywhere in the world with sufficient renewable energy and storage conditions. The Orca plant captures significantly greater quantities of carbon dioxide and instead of using it, converts it for storage through Carbfix's natural mineralization process. This involves mixing the carbon dioxide with water and pumping it deep underground where it is trapped in stone. This effectively removes it from the atmosphere permanently. Mining carbon from the sky instead of ground could represent a circular resource that could fuel airplanes and produce cement. But before launching such a large-scale project, Climeworks launched a pilot plant in Switzerland in 2017, which packaged the collected carbon up for commercial use in fertilizers, fizzy drinks, and synthetic fuels. Other carbon capture plants operated by various companies worldwide include Carbon Engineering, a Canada-based company, Global Thermostat, a US-based company working with other companies such as Coca-Cola, which uses carbon dioxide to make fizzy drinks, and oil giant ExxonMobil, which ranks among the world's top corporate emitters of planet heating emissions. Skytree, an Amsterdam-based company, uses plastic resin to filter carbon dioxide, and Solitaire Power, a Finland-based company, developed a solid amine sorbent for filtration. Now, talking about Tata Steel's new approach to carbon capture technology, Tata Steel, an Indian company, steps up to achieve its goal to be the industry leader in sustainability by reducing its carbon dioxide emissions by undertaking a two-pronged approach of carbon direct avoidance (CDA) and carbon dioxide capture and use in pursuit of decarbonization goal. Tata Steel, in collaboration with Carbon Clean, on September 14, 2021, inaugurated a 5 tons per day TPD carbon capture and utilization (CCU) plant at its Jamshedpur works, making it the country's first steel company to adopt such a carbon capture technology that extracts carbon dioxide directly from the blast furnace gas and reuse the captured carbon dioxide on site to promote the circular carbon economy. This carbon capture and utilization facility uses amine-based technology and makes the captured carbon available for on-site reuse. The depleted carbon dioxide gas is sent back to the gas network with increased calorific value. This project has been executed with the technological support from Carbon Clean, a global leader in low-cost carbon dioxide capture technology. Finally, moving on towards a Q&A section with experts, where today we'll be talking with Dr. Priyadarshini Karve on direct air capture technology. Annually, billion tons of carbon is released in the environment, but according to reports, the existing DAC plants are able to remove only 9,000 tons of carbon. So, in your opinion, is this technology significant and beneficial step in controlling climate change, keeping in mind the huge amount of costs involved?
Whether it is direct air capture or carbon capture, both these technologies are still in infancy. They are both costly and energy intensive processes. Therefore, we cannot really rely on either of these two technologies to play any significant role as solutions to climate change in the near future. Right now, we are at a very critical stage in our fight against climate change. We must start seeing a decrease in our carbon emissions in the next decade or so, if we are to have any realistic chance of keeping the global warming below 2 degrees centigrade in this century. So, at this stage, while we need to keep pursuing research in these technologies, we cannot really rely on these processes to help us meet the 2030 target of bending the carbon emission curve, or even the 2050 target of net carbon neutrality.
Tata Steel is using carbon capture and utilization (CCU) over direct air capture (DAC). Which technology, in your opinion, is a better solution to long-term sustainability, carbon control, and environment protection?
There is a fundamental difference between the two technologies. In carbon capture and use, you try to capture the carbon dioxide that has been produced in a human driven process and prevent it from getting into the atmosphere. In direct air capture, you remove carbon dioxide from the atmosphere and put it to some use and prevent it from going back into the atmosphere. In the exhaust of a factory, the carbon dioxide is a prominent component. In air, carbon dioxide is available in really very small quantity, just a few hundred parts per million. So obviously, it's going to be much more costly and energy intensive to harvest any practicable amount of carbon dioxide from air than from the exhaust. Also, spending the money and effort on capturing carbon from the exhaust is something that fits in with the idea that the one who pollutes is the one who cleans up. Therefore, I believe that in the long run, we should focus on CCU rather than DAC. Compared to technological solutions like CCU or DAC, restoring and nurturing local ecosystems is a least cost and easiest solution to implement for removing carbon dioxide from the atmosphere. Now, once you have green biomass growing and thriving, there are two options. You can just leave the ecosystem alone and let it conduct its natural carbon cycle, which is not going to contribute to climate change anyway. The plants will die, decompose, and release their carbon dioxide into the atmosphere. But new plants will keep on growing and removing the carbon from the atmosphere. There is, however, another possibility. What if you removed the dead or dying biomass from the ecosystem and converted it into biofuels? New plants will keep growing and removing carbon from the atmosphere, but the carbon from the dead biomass will provide an energy service before going back to the atmosphere. And this will allow some fossil fuels to stay in the ground in the process. So, in this way, we are achieving not just carbon neutrality but carbon negativity. Now, that is the theoretical idea behind BCCS. However, in practice, there are a lot of wrong approaches being justified in the name of BCCS. For example, if you are planting an energy crop,
instead of restoring the ecosystem, and then converting the harvest of the crop into fuel. One has to also consider the land use change and other environmental and social impacts arising from this. The environmental and social cost may turn out to be too high. So, yes, BCCS, if implemented in the right way, can be a better solution, but unfortunately, we are not seeing that happen in general.
Another technology being talked about is BECCS, bioenergy with carbon control and storage. What are your opinions on this technology, and is it a more feasible solution than CCU and DSC?
Compared to technological solutions like CCU or DAC, restoring and nurturing local ecosystems is a least cost and easiest solution to implement for removing carbon dioxide from the atmosphere. Now, once you have green biomass growing and thriving, there are two options. You can just leave the ecosystem alone and let it conduct its natural carbon cycle, which is not going to contribute to climate change anyway. The plants will die, decompose, and release their carbon dioxide into the atmosphere. But new plants will keep on growing and removing the carbon from the atmosphere. There is, however, another possibility. What if you removed the dead or dying biomass from the ecosystem and converted it into biofuels? New plants will keep growing and removing carbon from the atmosphere, but the carbon from the dead biomass will provide an energy service before going back to the atmosphere. And this will allow some fossil fuels to stay in the ground in the process. So, in this way, we are achieving not just carbon neutrality but carbon negativity. Now, that is the theoretical idea behind PECCS. However, in practice, there are a lot of wrong approaches being justified in the name of BECCS. For example, if you are planting an energy crop instead of restoring the ecosystem and then converting the harvest of the crop into fuel, one has to also consider the land use change and other environmental and social impacts arising from this. The environmental and social cost may turn out to be too high. So, yes, BCCS, if implemented in the right way, can be a better solution, but unfortunately, we are not seeing that happen in general.
Could there be any other technology or solution which could provide faster results with lower costs and can be incorporated by large number of countries collectively?
Either DSC or CCU are still far away from becoming practicable and significant solutions against climate change. But there are natural processes that can be used here and now to achieve more or less the same, but at a much lower cost. And that is to create as much native greenery around us as possible. If we have robust and healthy natural ecosystems thriving around any factories or industrial complexes, the green plants will remove and sequester the carbon through the natural process of photosynthesis. Please understand that I am not advocating planting of trees everywhere. I am advocating restoring and maintaining local ecosystems. Planting trees in grasslands or wetlands, for example, causes more harm than good. All the pledges around planting X billion trees, etc., is not the way forward. The right way to do this is for local ecosystems to be restored, and this has to be carried out on a planetary scale. That is really the right way to go.
As said, the technology such as DAC, CCU, etc., if incorporated rightly, may prove to be beneficial in controlling climate change. However, they alone cannot be long-term solutions. The primary solution, as suggested even by the COP26 meet in Glasgow, is to phase out consumption of coal by 2030s, as coal is single biggest contributor of climate change. More than 40 countries, including major coal-using countries such as Poland, Vietnam, and Chile, have committed to shift away from coal in pledges made at the COP26 Climate Summit. Some of the world's biggest coal-dependent countries, including China and the USA, did not sign up, but in a separate commitment, 20 countries, including the USA, pledged to end the public financing for unabated fossil fuel projects abroad by the end of 2022. India and China have demanded to change the agreement terms to phasing down of coal instead of phasing it out, since both the nations depend largely on coal consumption for power generation. However, the two nations may have to reconsider their coal consumption and shifting to other sources of electricity generation, as they have already started facing coal shortages. Both India and China face severe coal shortages in the months of September-October due to sudden reopening up of economy, weather changes such as heavy rains in India and winters in China, pollution control demands, etc. Many of the Indian thermal plants completely ran out of coal, whereas some have reserves up to 7 or 13 days. Delhi, Punjab, Rajasthan, and Bihar face severe power cuts and load shedding. Similarly, the three northeastern provinces of Jilin, Heilongjiang, and Liaoning among the worst hit by the power shortages in China. Hence, substituting fossil fuels with renewable energy is a better solution than carbon capture and removal technologies for a more sustainable future.